13A, index laws. Index laws are a topic that you've done several times in the past. You would have studied index laws from about year 9, so this should be quite familiar to you already, but just to make sure that we have gone over it so that we can apply it in future exercises. Our first index laws is that when you multiply two indices of the same base, all you need to do is add the powers. So the way that this works, for example, if I have 2 to the power of 2 times 2 to the power of 3, that means that I have 2 times 2, and then I multiply 3 lots of that. So in total, you can see that I've got 5 lots of 2, which is why it is 2 to the power of 5. So that's the understanding or the basis behind this law here. Let's practice. So part A, 2 to the power of 5 times 2 to the power of 7 is 2 to the power of 5 plus 7, which is going to be 2 to the power of 12. Same thing goes for part B. Just ensure that the base is the same. If the base is not the same, you cannot multiply them. So here the m's can multiply, but not the n. So that will be m to the power of 2 plus 4, n to the power of 3. That will be m to the power of 6, n to the power of 3. Again, we have for part C the same base, which is 3, and now I just need to add the powers. Collect the like terms. And for part D, I can add the like bases, or multiply the like bases, which are A and then B. The numbers also become multiplied, so you can go one at a time. Go first the numbers, so 4 times 2 is 8, and then each letter. I've got 2 A's here and 3 A's there, so in total I'll have 5. I've got 3 B's here and 1 B here, so in total I'll have 4. Same idea goes with dividing powers. So once again, if I've got 2 to the power of 5 divided by 2 to the power of 3, it means I've got 5 lots of 2 at the top, and I've got 3 lots of 2 at the bottom. So each 2 can cancel out, and that leaves me with 2 at the top, which is where our law comes from, that all we need to do is subtract the powers. So again, we're going to look at part A over here. I've look at each term by itself, or each variable. So I've got 4 x's at the top and 2 at the bottom. So if I get rid of 2 at the bottom, that will cancel out with 2 at the top. Same thing here, I've got 2 y's at the bottom. Take that away from 3, I'll be left with 1. So I will have x to the power of 2 y. With part B, you can decide to divide first, or you can add them first and then divide, because we have both the multiplication and division occurring. If I were to add them first, the top will be 4. You can see that you've got 2 lots of b to the power of x at the bottom and 4 lots at the top. So if I cancel that out, that will be 2 lots of b to the power of x, and then that is being multiplied with x to the power of 1. And when I multiply two indices, all I need to do is add them together. So that will be 3x plus 1. Same idea with C. You can either choose to multiply first then divide, or to divide then multiply. I prefer to divide first just because I believe it's a little bit easier. So 8 goes into 16 twice. If I cancel out 1a here, I will be left with 4 over here. If I cancel out with 1b there, I will be left with no b's there. Notice that I am not cancelling out with both terms. You will only do that if you have, or if you're adding or subtracting. So only if it's a subtraction or an addition would I cancel out with every term. The reason for that is that I have to split the fraction up in order to be able to cancel out first, but this is the shortcut. However, when I'm multiplying, this is all at the top. That's just one term. And so that's why I can divide only with one part at the top. I don't need to do it with both. In fact, you can't do it with both. So this leaves 2a to the power of 4 times 4a to the power of 4b to the power of 3. I have nothing left at the bottom. And now all I have to do is multiply them together. So 2 times 4 is 8. At the top, I've got 4 a's here, 4 a's here, gives me 8 a's, and then I've got 3 b's. Next law is that anything to the power of 0 is 1. The way that that works is, say I have x to the power of 4 divided by x to the power of 4. Our law tells us that all we have to do is subtract the two powers. So 4 minus 4 gives me x to the power of 0. I also know that if I have x to the power of 4 and x to the power of 4, if I cancel them out, that will equal 1. And that is why we get the law that anything to the power of 0 is equal to 1. The next law as well, within this same slide, is that anything to a negative power can become positive when I take it to the other side. So whether that's at the top or the bottom, if you simply take it to the other side, you can change the sign. So for example 3, evaluate each of the following. So all I have to do is take the 2 to the power of 2 to the bottom to make it positive, and then I can work out what that will be, which is 1/4. If I have something all to the power of a negative, I can flip the fraction, and that changes the sign as well, because that has flipped the entire fraction, that's taken the reciprocal of it. Then I can put it to the power of, then 2 to the power, 2 Then 2 divided by 1 is just 2 to the power of 4, which will be 16. Same idea with c, you can see that negative, so step 1 is to flip the fraction, so take it to the other side to get rid of that negative. And then because all of this term is to the power of 3, I have to put every number to the power of 3. 4 to the power of 3 is 64, and 3 to the power of 3 is 27. Index law 3 is raising to the power. So if we have a power to another power, what we need to do is multiply it. So an example is if I have a squared squared, the way that that works is that I have a squared, and then that's multiplied by another a squared, which is 4. So that's actually a bad example. So for example, if I have a squared to the power of 3, I will have a squared times a squared times a squared. So you can see I have 3 lots of these 2's. So that will end up being 2 plus 2 plus 2, which is 6. Or the other way to think of it is 3 lots of the 2 is 6. And so that's why you must always multiply the powers. So if we go on to the examples for A, we've got 5 raised to the power of 3. So that will just be 5 times 3, which is 15. Part B requires you to do a couple of things. So the first thing is I can see I've got a negative, so I have to flip the fraction over to get rid of that. And at the same time, I can multiply out the 2 and the 3, which is going to be 6. So that's 2 to the power of 6, which is 32. That's 2 to the power of 6, which is 64. And then same idea for C. Here I've got 3 raised to 2, so that will be 6. You could do it, it doesn't matter which order, whether you take the negative first or multiply it. I'll just multiply this out, so that's negative 2. And then that means that's b to the power of 6 over b squared. And then I've got 2 b's at the bottom, 6 b's at the top, so I will cancel that out to get 4. The next law is products and quotients. So we have come across this before, but the general idea is that every single number within the bracket is raised to the power. So here I've got a to the power of n and b to the power of n, and same idea at the bottom, a to the power of n, b to the power of n. So now we just need to simplify this. I will be raising every single number to the power of 3. 2 times 3 is 6, 3 times 3 is 9, Now, what I can do here is, because it's a negative, I can either bring the negative in, or I can take this entire term to the bottom straight away. So I am going to take it straight to the bottom. And whilst I'm doing that, I'm also going to raise everything to the power of 2. So that will be 3 to the power of 2, a to the power of 2, and b to the power of 8, because 4 times 2. It's not negative because now it's at the bottom. All I have to do now is simplify. So 2 to the power of 3 is going to be 8. 3 to the power of 2 is 9, so that's at the bottom. I have 2 a's at the bottom and 6 at the top, so that cancels out to give me a 4. 8 b's at the bottom, 9 at the top, that cancels out to give me 1. So that will be a to the power of 4 and b. There is nothing left at the bottom. For part B, we have quite a few things going on, and it doesn't really matter which order you decide to do each of these steps in, but we'll try and do it in the most simplest way. First of all, I can see that this entire term is raised to the power of 3, so that means every single number is going to be raised to the power of 3. I can see that we are dividing. Now, remembering that when we divide a fraction, what we have to do is change the sign and then flip the fraction over. So some people think of it as keep, change, flip. So what I'm going to do is I'm going to raise the first term to the power. So that will be 2 to the power of 3, a to the power of 9, b to the power of 6, all over a to the power of 3, b to the power of 3, c to the power of 6. Now I'm going to multiply, so I take this term to the bottom. Notice that I'm not taking it to the bottom because of negative, so no negatives are going to be affected. I'm taking it to the bottom because I have changed this particular sign here. So that will be 1 on, and at the same time, I'm just going to raise everything to the power of 3. Now, before I can begin simplifying, I just need to recognize that Now, before I keep simplifying, I just need to recognize that there is a negative here, which means this term needs to be taken to the other side. And when it's just one term, I generally like to highlight it like this and put an arrow to the other side just to remind me that I need to take it over. I can also go ahead and start simplifying. So I have 3 a's here and 9 at the top. So that will be gone with 6. 3 b's here, 6 at the top. That will leave 3 left over. I have 3 a's at the bottom. I can also cancel out diagonally. So can cancel out that way. So if I take 3 from the bottom there, that will leave me with only 3 at the top. I cannot simplify with the b because I'm taking that to the top. So do not ever touch a term that has a negative power. I've got 3 c's at the bottom, but nothing at the top, so I can't touch that yet. Okay, and now I'm going to write out what I have left over. So 2 to the power of 3 is 8. I've got 3 a's left over, 3 b's left over. I have 6 c's left over. I'm going to take this b, 3 to the power of, to the top, and 3 c's to the bottom. And finally, because there's nothing else that I can simplify, I'm just going to multiply this so it's one fraction. So that'll be 8a cubed, b, I have 3 here plus another 3 is 6, all over, I've got 6 c's here, 3 c's here, so that will be a total of 9. If I have a negative base, you need to remember that if you put it to an even power, so such as squared or to the power of 4, it will always result in a positive number. The reason for that is that every time I multiply a negative by itself, it becomes positive. So if I've got 2 of them, that will become a positive. If I've got 4 of them, there are an even amount so that the negatives cancel out. However, if it's odd, it will always result in a negative. The reason for that is that if I've got 3 of them, these will give me a positive, but I'll always have 1 left over. So just keep that in mind whilst you're simplifying. So here, negative 3 to the power of 4. So 3 to the power of 4 is 81, and then because it's an even power, that negative is going to go. So we won't have a negative. So that will just equal 81. Here it is to the power of 3, so if I do have a negative, it's going to remain. So negative 5 to the power of 3 and a to the power of 3. So ensure that negative stays. 5 to the power of 3 is 125, a cubed. Same idea here again, it's an odd power, that means that negative will remain. So that'll be 2 to the power of 3a cubed times 3a squared, and then I just need to simplify that out. So 2 cubed is 8 times 3 is 24, and that's a to the power of 3 times 2, so add the powers, that will be 5.